This lesson is Chapter 6, Section 7. We're covering binomial experiments when the probability of the event is equal to 1/2. And I'll go through what all of that means. For an experiment to qualify as a binomial experiment, it must meet 3 requirements. The first one is that there needs to be a fixed number of trials. So what this means is we need to set exactly how many times we're going to do the experiment. Like we're going to flip the coin 5 times, or we're going to answer 10 questions on a true-false test. We need to set the number of times that we're going to do it. So there needs to be a fixed number of trials. The next part is you'll notice in the word you see by, and that means that we need to have 2 outcomes. But the 2 outcomes also need to be mutually exclusive. So we're going to have 2, there are exactly 2 mutually exclusive outcomes. And remember, mutually exclusive means that there is no overlap. Like heads and tails are mutually exclusive. Rolling a die and getting even and then odd, that's mutually exclusive. But something like rolling a 3 or an odd, that would not be mutually exclusive because the 3 and the odd have outcomes that overlap. So no overlap on this. Also, the trials need to be independent of each other. So what happens on the first trial cannot affect what happens on the trials thereafter. Okay, in order to find probability, the first thing we need to know is the total number of ways something can happen. So this whole section focuses on the total number of ways something can happen. So you might write out to the side, total number. We'll need that for when we find probability. So the first one says, how many outcomes are possible if you flip a coin 4 times? If you think back to day 1 when we talked about the counting principle, we talked about first looking at how many times we're doing the experiment. And for this, we're flipping the coin 4 times. So we would draw 4 blanks. This representing the first flip, the second flip, the third flip, and the 4th flip. And then we look at how many outcomes are possible each time. Each time we have heads or tails. So there's 2 outcomes possible each time. So 2 times 2 times 2 times 2. And we can look at that as 2 to the 4th, or 16. The next one says, how many ways are there to answer a 5-question true-false test? So we have 5 questions, which is like we're doing the experiment 5 times. So we would draw 5 blanks. And in each blank we would put a 2 because there's 2 possible outcomes each time, true or false. And then using the counting principle, we multiply. And that's the same as saying 2 to the 5th, or there's 32 ways to answer the true-false test. This should have a ways on it also. We're looking for the number of ways, number of possible outcomes, how it can happen. The next one says, how many ways are there to have a family with 3 children? Like you could have all girls or all boys. How many different ways are there? Well, we have 3 children, so we draw 3 blanks. Each time you have a child, you have 2 options, boy or girl. So there's 2 options for the first child, times 2 options for the second, and 2 for the third. So that's 2 to the 3rd, or 8. And then the last one says, how many outcomes are possible when you do a binomial experiment n times? Well, when we did it 4 times, it was 2 to the 4th. When we did our experiment 5 times, it was 2 to the 5th. When we did our experiment 3 times, it was 2 to the 3rd. So if we're going to do the experiment n times, that would be 2 to the nth. So now we know if we flip a coin 20 times, we could just do 2 to the 20th, and that would tell us how many outcomes are possible if you flip a coin 20 times. Okay, now we're going to talk about how many ways there are to get what we're looking for. We know that part of probability is having the favorable outcomes over the total. So now we know how to find the total. We need to look at how to find the number of favorable outcomes. If you flip a coin 5 times, how many ways are there to get heads twice? We talked about this a little bit last class. One way is to get heads, heads, and then tails on the next 3. And so we have 5 letters, so we can do 5 factorial over, we look for our repeats. We have 2 heads, so 2 factorial, and 3 tails, 3 factorial. We know if we did 5 factorial that we'd have a lot of repeats in there because you can't tell if these 2 heads have been switched. And so dividing gets rid of all of those repeats that look identical. And then if we simplify this, 5 times 4 times 3 factorial over 2 times 1 times 3 factorial. That looks like a 7. Let's fix that. There we go. We look for everything we can cancel. The 3 factorials cancel. 2 goes into 4 twice. 5 times 2 is 10. So there are 10 ways to get heads twice. The other way to look at this is if we look at the 5th row of Pascal's triangle, and if you can get out, I would pause your video real quick and get out Pascal's triangle. And then row 5 says 1, 5, 10, 10, 5, 1. We have 5 flips, so we go to row 5, and we want heads twice, so we go to the second diagonal. Now remember that we start counting diagonals with 0, so this is 0, 1, 2. There's 10 ways. So we can use the formula, or the number is also hidden in Pascal's triangle if we want to find it. If you take a 6-question true-false test, how many ways are there to get 4 correct? So we have, let's try this again. We have 4 correct, and then that means we'll have 2 that are incorrect. Now we have 6 letters, so we're going to do 6 factorial on top, divided by our repeats. We have 4 C's, so 4 factorial, and 2 I's, 2 factorial. And we can simplify that. 6 times 5 times 4 factorial over 4 factorial times 2 times 1. Once we have it written out, then we can cancel. The 4 factorials cancel. If we look, 2 cancels with a 6. And when we multiply 3 times 5, we get 15. So pause the video and go to row 6 on your Pascal's triangle and diagonal 4. And what do you find? You should get that answer is also 15. On the next one we have 8 cousins, and how many ways are there for 4 of them to be boys? So we have 4 boys, and that means we have 4 girls. And we want to know how many ways that order can happen. So we have, let's give ourselves a little more space, 8 factorial over 4 factorial times 4 factorial, 4 boys and 4 girls. Oops, that should be a 5. Times 4 factorial. And we have the 4 factorial on the bottom, that those will cancel, but we need to write the other one out. Now our 4 factorials cancel. And then we have a little more work here. 4 cancels with the 8 twice. Then you could cancel the 2 and the 2, and 3 goes into 6 twice. This is just one of the ways you could simplify that, and there are 70 ways. Now for all of these you can use Pascal's triangle, but you notice when you start getting into 8, that means you need to make the 8th row of Pascal's triangle. Or what if we had 20 cousins and we wanted to check the same thing? Then you'd have to go clear down to the 20th row of Pascal's triangle. Well, in situations like that, it's going to be a lot easier to use the formula than it would be to make Pascal's triangle. So now we've looked at how many ways something can happen total, and we've looked at how many ways we can get what we're looking for. So now we're going to put those together for probability. We want the favorable outcomes over the total number of outcomes. For this example, we have a coin is flipped 6 times. So if we want to find the total number of outcomes for 6 flips, we know that there's 2 outcomes possible each time, so 2 to the 6th is 64. So there's 64 total possible outcomes each time. So we know we're going to use that for our probability. And then we need to figure out how many ways each one of these things can happen also. So first we want to know how many ways there are to get heads exactly twice. So that means we'd have heads, heads, and then 4 tails. So that's 6 factorial over 2 factorial times 4 factorial. 6 times 5 times 4 factorial over 2 times 1 times 4 factorial. That's getting a little messy, isn't it? The 4 factorials cancel. 2 goes into 6 3 times, and 3 times 5 is 15. So there's 15 ways to get heads exactly twice, but what we want is the probability. It says find each probability. So the probability that that happens is 15 out of 64, because we know we had 64 total outcomes. Now our next one says getting tails exactly twice. If you look at this one, it might look similar. Here we have tails, tails, heads, 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 heads. So you have 6 total, 2 tails, and 4 heads. That's going to look exactly like this problem up here. 6 factorial times 2 factorial over 4 factorial. So that's going to be 15. And then again, if we want the probability, there's 15 favorable outcomes out of our total 64. The next one says getting exactly 5 heads. And we talked about this one in class some. When only one of them is different, that means we want 1 tail and 5 heads. Well, our tail could be the first one, or it could be the second flip, or the third, or the fourth, or the fifth. Oops, I'm missing a head. Or the 6th. So there are 6 ways for this to happen. You can calculate that using the formula, but we don't need to. So you have 6 ways out of the total 64. And this one simplifies, our others didn't, to 3 over 32. Our next one says getting exactly 4 tails. So that's going to be 6 factorial over, you have 4 tails and 2 heads. That's the same as the ones above it, isn't it? 15. And so the probability that that happens is 15 out of 64. The next one says getting at least 5 heads. Anytime it says at least, we've got to give a little extra thought to this one. So that could be 5 heads or 6 heads. Well, we just learned in C up here that there's 6 ways to get 5 heads, so there's 6 ways for that. 6 heads means all 6 coins would have to have a head. There's only one way for that to happen, so 6 ways plus 1 way is 7 total ways, so our probability for that is 7 out of 64. The last one says getting 2 or more heads. So for that one, we could have 2 heads, or 3, or 4, or 5, or 6. Some of these we've already calculated, so we'll go ahead and write those down. We said there's 1 way to get all heads. We said there's 6 ways to get 5 of them to be heads. We learned that there were 15 ways for 4 of them to be heads, and 15 ways for 2 of them to be heads. For 3 of them to be heads, we'd do 6 factorial over 3 factorial times 3 factorial. Cancel. 3 times 2 is 6. So there's 20 ways for 3 of them to be heads. You could have also found that by looking at the 6th row of Pascal's triangle. If we add up all of these ways, 15 and 15 is 30, 50, 57. So the probability, there's 57 ways, but we know there's still 64 total. The probability that that happens is 57 out of 64. All right, we have a couple more. The first one, what is the probability that a family with 6 children has exactly 4 boys and 2 girls? This is very similar to what we were just doing. There's 6 children, so the total number of ways that can happen is 2 to the 6th, which is 64. To have 4 boys and 2 girls, boy, 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 girl, girl. This should look familiar. We end up with 6 factorial because there's 6 children, 4 boys, 2 girls. We computed that several times just above on this page, and so that was 15. And the probability of that happening was 15 out of 64. Now on the next one, we're going to have to do a little bit more thinking. It says you take a true-false test and guess at all 12 answers. What is the probability of getting a score better than 80? Well, there's 12 questions. The first thing we need to figure out is a score of 80 means how many correct. And so we know that to find out how many you got right, or what your percentage is, you take the number you got right, say you got 9 correct out of 12, and you can do 9 times 12. That's a 75%. But we wanted to get a score better than 80. So if you continue and do 10 over 12, 11 over 12, and 12 over 12, you'll find that all of those have a score higher than an 80. So we're looking to get 10, 11, or 12 correct. So 10 or 11 or 12 correct. So right now we're looking for the favorable number of outcomes. To get all 12 correct, there's only one way to do that, and that's just to have them all right. To have 11 correct, that means you only miss 1. So we know that there's 12 ways to do that because you could miss question 1, you could miss question 2, you could miss question 3, and so on all the way to question 12. So there's 12 ways for that to happen. Then for 10, we're going to have to do a little more work. There's 12 questions, so 12 factorial. We want 10 to be correct and 2 to be incorrect. So 12 times 11 times 10 factorial over 10 factorial times 2 times 1. Our 10 factorials cancel, and then we look to see what else simplifies. Well, 2 goes into 12. 6 times. So there's 66 ways to get 10 correct. So we'll do 66 plus 12 plus 1 is 79. So there's 79 favorable outcomes, but we need to know how many total outcomes. Well, there's 12 questions. There's 2 options on each question, so we're going to do 2 to the 12th, which is 4,096. And so our probability is our favorable outcomes, 79, out of our total, 4,096.